So my name is Sven van der Molen. I'm leading a group at the Leiden Institute of Physics, and we are especially interested in nanoscience, in properties of materials that are really small in at least one direction. And for that we use a very special type of experimental setup which is called a low-energy electron microscope. LEAM is a type of electron microscopy that is really special. There are only 30 LEAMs or so in the entire world. And ours is then specifically nice because it contains aberration correction. And we have a resolution of only 1.4 nanometers, which is the world record at the moment. We use it as a microscope on the one hand, but we're actually extending its properties to making it a real broad physical measurement device, if you will. Daniel Gelen is a PhD student in my group, and he's working on a very special project in which he's devising a new electron microscopy technique, and it's called EV10.
So the traditional way of using a LEAM is to look in reflection. So you shoot your electrons from the front, you illuminate from the front, and then you look in reflection.
And one thing we realized is that if you have an electron gun giving electrons coming from here that we can image in reflection, we may as well turn this off and have an electron gun at the other side of the sample that brings electrons through the sample towards the detector.
And this in principle should allow you to look inside materials, because if you look in reflection you only look at the front of the sample, but if you illuminate from behind, the electrons must have traveled through the sample, so you get information of the interior. TEM is a technique very often used in biology, so that's transmission electron microscopy. But because you want to send these electrons through your sample, they need some kick. So what they use, they accelerate their electrons with 100,000 volts. So it's pretty high energy. And this energy is high enough to really damage the sample.
So in LEAM what you want is that the electrons that reach the sample have a very low energy. And if Daniel gets this to work, and he is very far in this, he's really creating a new technique that doesn't exist on Earth yet.
So the transfer, yeah.
Daniel,
What's that?
look.
Let's see, what is it?
These are the exposures I made.
Ah, nice. You're still recording or not?
No, but now
I think it's good if a group is somewhat diverse, because if you're all the same, you don't get inspired. You get creative by talking to people that will have a very different way of thinking about the same problem. And this will make you creative as a group.
So during the lunch breaks and the coffee breaks, that's where I usually see other people, and then we can talk about our problems, and they come with suggestions how to solve these problems. That's a nice thing of what we do. We encounter one problem, we try to solve it, and the solution can be used in multiple places. And this is the idea of it. But the thing in science is that if you try to do something, it never really goes as you plan. And that's where you learn stuff.
So when we read a physics book, we tend to read it and think, well, of course, this makes a lot of sense. But what we should realize is that these people that came up with these equations and did these experiments, they struggled. And 90% of the time they were wrong. And what we are left with is only what was right. And if you do research, you have the same thing. 90% of your ideas are probably wrong, and 10% are right. And this is something, as a scientist, that you have to find out what is right and what is wrong. And for that you do experiments, and you interact with people, and you think, and you read. And finally, you hope to reach consensus with yourself and the community that something is the way you think it is. And this means that you are, as a person, are involved. We are not robots doing research. We are really excited by a certain development, and we can be really depressed if something doesn't work, and then we can be really happy if something is actually succeeding.
Then you're really happy, of course. And then I am really happy, because then you've done something that nobody's done before.